All right, let's move on to routers. I'm looking at Ryan. He says there's not a whole bunch of questions. There's nothing he hasn't answered yet, so we'll keep rolling here. Routers. Let's talk about routers for just a little bit here. What, of course, is a router? Well, it is the WAN to LAN bridge, basically. You have a WAN, which is a wide area network, which is the network, or the internet, excuse me. And that is, of course, what we do not have any control over. That's what the service provider gives us. That's where IP addresses are assigned one time, and you don't have the ability to change those or see those or do anything about it. The local area network, or the LAN, is the one that you do have control over, and that is the one that actually is duplicatable and repeatable, and that you're putting into people's homes and businesses every day. What the router does is, like I said, it kind of is the bridge between those, and it connects those two networks. So a router is doing several things. It's generally a DHCP server, it's also a firewall, and it's talking to two networks, both the internal and the external networks, and bridging the gap and allowing that gateway or that road out of the neighborhood to be able to happen. There are a couple of different router types. There is the wireless router, which is kind of an all-in-one device. It's a router, a small switch, and a wireless access point all built into one. And these are, generally a consumer type product, and they generally have a little bit more basic routing features built into them, which is sufficient typically for homes. But if you're doing something a little more complicated, it might not have the options and the features to do what you need it to do. One of the things, the other type is wired routers. And these are much more of a dedicated device. They do not have an access point in them. They're just a router and a small switch. And they generally do have more advanced features in them. They're meant to be mountable in a rack. They come with rack ears. And generally, these are for larger homes or larger networks, small business, small enterprise networks, that type of thing. They usually have more robust chipsets and feature sets that go along with them. That brings up the question, well, which router do I want to use? Well, a lot of it comes down to, what kind of features do you need? How many devices are going to be on the network at a time? And especially with wireless routers, placement becomes a very important part of this because where it's broadcasting Wi-Fi. And if you stick it over in the far left corner of the home, you might not have very good signal over in the far right corner of the home. So placement becomes a critical issue with when using a wireless router. And kind of the idea you might want to keep in mind with a wireless router is, can I, number one, put it in a place where I think it might be able to cover just about all of the area that I need to cover? Now, if it doesn't, of course, our wireless routers have our wireless controller built in, so you can add and expand up to two more access points and wirelessly roam across all of those, or seamlessly roam across all of those devices. So there is a little bit of expandability in our devices, but most of the time the mindset should be, hey, look, is this going to cover everything I need based upon where I can put it? And if not, then I do have a way out that works really well, but I kind of want to try and cover everything with the wireless router. With a wired router, of course, it does not matter where you put them physically. You can put them in a cabinet, you can put them in a rack, you can put them in a closet. Doesn't matter because there is no Wi-Fi being broadcast from them. As long as they're there on the network somewhere and running the network, you can put them wherever you physically need to. They're really, really flexible from an installation standpoint that way. So as far as setup and configuration, some of you may know that recently we actually released an easy setup app for the wireless routers. And this is a really cool app. It can literally take you from, pulling the router out of the box to a fully functioning network in about 2 to 2.5 minutes. It's very, very quick. Part of the setup process for this easy setup app is it will look for a firmware update for the router. And if there is one available, then of course it downloads that and installs it for you. And so it increases the time of that process to about 7 or 8 minutes or so. But all in all, still very, very quick from going out of the box to a network, both wired and wireless, up and running. The Easy Setup app, of course, is available on both iOS and Android, and because they have to rely on wireless to be able to connect to anything, they are only available with the wireless routers currently. Obviously, it's kind of hard to connect to a wired router that does not have wireless built in. It's a really, really cool and easy way to do things, so if you haven't tried it out, please download the app and give it a shot. It works really, really well. The other way to do it is the way we've always had, which is to log into the router using the IP address in your browser. The reality is the setup is not any harder. It's just as easy. It's just a different way of doing it. And the reason why I say it's just as easy is because when you log into the router, the default page that comes up is going to be your quick setup page, and everything that you need to set that network up and get it up and running, both wired and wireless, is on this one single page that comes up by default. As you can see here on the left, I've got a screenshot from one of our wireless routers that has both the 2.4 and the 5 gigahertz wireless frequencies included on that page. On the right-hand side, I have one of our wired routers, which has the same basic type of setup, just minus the wireless, because of course it doesn't have wireless built in. So as you can see, whether you're using the Easy Setup app or whether you're using a laptop to log into the router, either way is fine. They are both very simple and easy to get a network up and running within just a few minutes. As far as switches go, changing gears here just a little bit, a switch is different from a router. It does not talk to two different networks. It basically sits on one network and talks to all of the devices on the network. So it transfers the data between all of those devices that are on the local network. There are many different types of switches that are available, and we have just about every type that is available out there as well. There's unmanaged, there's managed, and then we have two basic series, which are kind of a marketing term. We have the AV series, which means they have ports on the back. So if you want to put them in a rack and have a nice clean front look on the front side there, and have all of your connections along with all your AV connections in the back, and have the ability to lace it out on the back and make it all look really nice and tidy on the backside, perfect. That's great. We have lots of products for you. The security series is the same type of switches with the same basic capabilities, but they have ports on the front. Now, these are just marketing terms, AV series versus security series, because the reality is a switch is a switch is a switch. And you can take a security series switch and have it run AV gear just as easily as you can take an AV series and have it run surveillance cameras or data centers or something like that. So switches are just going to pass data. It just depends on, do you want the ports on the front or do you want the ports on the back? And then lastly, of course, we have switches that are managed and have power over Ethernet in them, or PoE. So depending upon what your needs are, whether it's the little 5-port switch that you see there pictured or a large 52-port managed PoE switch, we've got everything in the range to try and take care of whatever need you might have. Now, as far as switching or connecting a switch to the network, there's a couple of different ways that you can do it, and there is a best practice way that we highly recommend. If I have this graphic here, and on the left-hand side, I've got my internet connection going into my router, and then let's say in this example, I have 3 different switches in my network. I've got a main one in my rack, and then I've got 2 different rooms in different parts of the house where I need to be able to have a switch so I can connect multiple devices to each one of those. And I take those switches and I connect each one of them directly back to the router. That will actually work, but it's not the most efficient way to make things work. What I would highly recommend as a best practice is take one cable from your router to your first switch and your main switch, and then plug everything else, including the other switches, into that first or main switch. And the reason for this is there's several things, but mostly it's because let the switch do the job that it was built to do. They are very, very capable. We'll talk about that in a moment. And the other thing is, if you remember, the router's already doing several things. It's already a DHCP server and a firewall and talking to several different networks. And yes, it can do that because it does have a small switch built in, but why make it if you don't need to? Let the switch handle all of that data traffic on the local network. And here's another reason why you want to use a switch. When we say wire a switch up and have your network topology so that every device goes into the switch itself instead of through the router, the part of the reason for that is because one of the unique things about Luxel switches is they are what we call full speed. Now let me explain that here for those who may not know. When I say a full speed switch, every switch has a backplane on it, and a backplane is kind of like a motherboard inside of a computer. And if I have a full speed switch, it means I should have double the amount of ports that are on that switch. So for example, if I have a 24-port switch, I should have a 48 gigabit backplane on that switch. And as you can see, 48 gigabits, not megabits, but gigabits, is a huge number. That's an enormous amount of data that you can pass through that switch. So you can have all these things going on and multiple Netflixes and surveillance cameras and video over IP, and the switch doesn't even breathe hard because it's got so much capacity. It just is like, all right, cool, I'll do whatever you ask me to do. So the unique thing is, whether you're talking about the little 5-port switch all the way up to the big 52-port switches, every switch in our line has a full speed backplane, which is part of the reason why so many companies external from us are recommending our switches for high data capacity networks, because it works really, really well and they just have plenty of bandwidth to do whatever it is you throw at them. So you want to use that switch for all of that switching capacity and let it do its job and not have to bog down the router with doing another job versus what it's already doing. If you're going to use a PoE switch, this is where, unfortunately, you do have to do a little bit of math. And I don't like math just as much as all of you don't, I'm sure. But this is where you do have to do a little bit, because you have to know what the amount of power each device is going to draw so that you don't overdraw the available power budget that the switch has available to deliver. So, if you've got, a 10-port or a 10-watt device, for example, you could probably, based upon the power budget, you can determine how many devices you can plug into that switch without having a problem. So the bottom line here is, know the requirements of your devices so you don't overdraw the power budget, and make sure that you use a switch with a full speed backplane so it can do whatever it is you need it to do. Now, on managed switches, there is one thing that I want to point out that I think is very important, because what we don't want to have happen is a phone call that used to happen to tech support quite often. Fortunately for all of us, it does not happen very often anymore, but I want to point this out anyway because it's still something that you need to be aware of. When you're using a managed switch, please realize there are 2 places to save inside that managed switch. And the reason for this is because most managed switches from most manufacturers do not have a factory reset button. And so if you are into that switch and you're configuring things, and let's say you, for example, make a mistake and you end up locking yourself out and you can't do anything inside that switch anymore, there's no reset button. So the only thing you can do is pull the power plug, wait a few seconds and plug it back in, and let it boot back up to its default settings. And then you can get back in and continue to configure, or in this case, start over again. Our switches do have a factory reset button, so there is always that option. However, there's still 2 places to save. And the reason I bring this up is because I don't want to create a service call for you unnecessarily. Let's say that the phone call that we used to have happen all the time went something like this. My system's been working great for 8 or 9 months, and now something has happened and nothing works, and I can't figure out what's going on. And 10 or so minutes into that conversation, it was revealed that a storm went through the previous night, and the power went out, and the switch got rebooted as a result of the power going out and coming back on. Well, what happened was that switch booted back up into its default configuration instead of the way that you had set it up to be configured. So there's 2 places here, and I've got a screenshot here of just the IP address page on the switch. Now, this is going to be true with any page on the switch, whether you're setting up the IP address, VLANs, IGMP, spanning tree, whatever the case is that you happen to be configuring that switch for. When you make whatever adjustment it is on whatever screen and you go down to the bottom and hit save, please realize that it is an immediate save and it saves it into its current running configuration. But it is not, however, a permanent save. So if the switch gets rebooted, it will revert back to its default, which is not the way that you set it up. When the switch is set up, whether you've just changed one screen on here or multiples or whatever the case is, and the switch is now running the way that you want it to run, you want to go to Administration, Save Startup Config, and click the Save Configuration button under the Administration section. And once you do that, the switch will now be permanent with the settings that you have set it up with. So it will survive reboots and power cycles and all of that, and every time it boots up, it will boot up to the way you need it to be set up and the way that you have configured it rather than its default configuration. So please remember, with managed switches, you do have to save in 2 places, and you do that, you can save yourself headaches and unnecessary service calls.